All right, so now we're going to look at changes in the equilibrium constant. So there was a sentence at the beginning of this lesson talking about that the equilibrium constant is constant at a constant temperature. That was a lot of word constants. The equilibrium constant is stable, I guess I could say, but only when the temperature is stable, and we'll talk about why. So what is the effect on temperature changes on the equilibrium constant? When the temperature changes, the value of KEQ changes. The only way to understand this is to look at some examples. So let's consider an endothermic reaction, so something where heat is a reactant. The equilibrium concentration for this is products over reactants, so C over AB. If I were to increase the temperature of the system, the equilibrium would shift to the right. Okay, we're going to increase heat, so we want to consume that reactant, so we're going to shift to the right. So the concentration of the product will increase, and the concentration of the reactants will decrease. So what would happen to the value of KEQ, right? So if the concentration of the product, so aka the concentration of C, was to increase, is KEQ going to get larger or smaller? Well, the value of KEQ will increase. And because there's just this shift to the right and there's not this like coming back from it versus, and we'll talk about this in a second, but versus changing the concentration of a species where you get a spike and then you're just bringing that spike down and everything accommodates, this is like a permanent shift to the right. Right? So as long as you increase the temperature and then stay at that new temperature, then you've had this shift to the right where you have more products and less reactants. If you were to decrease the temperature, the equilibrium would shift to the left and the concentration of the reactants will increase and the concentration of the product will decrease. If you decrease the concentration of the product and increase the concentration of the reactant, then the value of KEQ will decrease, right? And as long as you stay at that stable temperature, you're going to have a new KEQ at that temperature. So here's another example that I want you to try. Given the equation for this time an exothermic reaction, so we have heat as a product, first thing I want you to do is write the KEQ for this reaction. So it's going to be the concentration of the product over the concentration of the reactant. If the temperature was increased, the equilibrium would shift which way? Well, it's going to shift to the left because you're going to consume that extra heat. The concentration of the reactants, now you can either put reactants here or you can put C and D, right? I kind of designed this either way. So the concentration of C and D would increase, which are your reactants, and the concentration of E would decrease. Now, because we're decreasing the concentration of the product and increasing the concentration of the reactant, what would happen to your KEQ? Well, your KEQ will decrease. Okay, what about this next one? When the temperature is decreased, the equilibrium will shift where? The equilibrium will shift to the right. Right. So the concentration of E will increase, which is the product. So you can write either one there. And then the concentration of your reactants will decrease. If you increase the concentration of your product, your KEQ will increase. Okay, so we've just done two examples. One was an endothermic reaction, one was an exothermic reaction. Not that that really mattered, because as long as you treat heat as a reactant or a product and determine which way to shift, we've looked at the effect on KEQ. So this next one's going to be a little bit of a puzzle. For the reaction X plus Y goes to Z, it has a KEQ of 235 at 100 degrees Celsius. If the temperature is raised to 200 degrees Celsius, then the value of KEQ goes up or down to 208. So what we want to determine is looking at whether this was an increase or decrease in temperature, did that cause an increase or a decrease in your value of your equilibrium constant? From that, you should be able to tell if the reaction was endothermic or exothermic. So let's look at this. We've got X plus Y. I'm going to leave room to write my heat term depending upon where it goes, and then I'm going to determine from there if it's exo or endo. Now, at 100 degrees Celsius, my KEQ is 235. When I increase the temperature to 200 degrees Celsius, my KEQ went to 208. When I increase the temperature, my KEQ went down. So for your KEQ to go down, it means you have to favor the what? For your KEQ to decrease, you have to favor the reactants. When you increase temperature, you move away from the heat term. So if I'm favoring my reactants by increasing the temperature, it means I'm moving away from my heat term, which means my heat term must be on the right, which means that this is an exothermic reaction. So in my reasoning there, I could write this a little bit better. Type it. My printing, it's not the greatest. When the temperature was raised, the KEQ decreased. Since the reaction would be moving away from the heat term, it must have been exothermic for the reactants to be favored. And there's probably a better way I could write that, but something along those lines, that when the temperature was increased, the equilibrium constant decreased, which means we had to be favoring the reactants. So for the reactants to be favored when we're moving away from the heat term must have been on the right-hand side, and it must have been an exothermic reaction. Okay, hopefully that'll stay when I click away. All right, next page. So the key thing here, though, is that only, and this would be a great multiple choice question, but only temperature can affect the value of KEQ. Concentration, pressure, volume, and catalyst do not change the value of KEQ. Now, this is a rule that you should just memorize, but it's hard to memorize something when you don't understand why. So here's my explanation of why. So the first thing let's look at is concentration changes in KEQ. When you change the concentration of reactants or products, it does shift equilibrium, but it doesn't change KEQ. So let's take an example of A plus B goes to C plus D at a KEQ of 4. When you add C, your KEQ is going to be temporarily raised. It's going to be temporarily greater than 4. But Le Chatelier will tell you to shift to the left to produce more A and B and decrease the concentration of C, also using up the concentration of D, until it gets back to a KEQ of 4. That's when it knows to stop, right? So it kind of just like has this shift, and then it counteracts it, and you might have a new concentration of C, D, A, and B, but the ratio of the products to the reactants will be back to 4. So the key idea here is that the system will shift to restore that same KEQ value that it had before the change in concentration. Pressure and volume works very much the same way. If the pressure or volume changes, the equilibrium may shift only if the number of gas moles of gas differs on each side. So remember that one where it was like 2 moles of gas and 2 moles of gas on the left and the right, and there was just no effect if you changed the pressure or the volume. So if there was differing numbers of moles of gas, then again, you're going to shift just enough to restore you back to that equilibrium ratio. And then catalysts, just like we've said before, it speeds up, forward, and reverse. So there's actually no shifts at all. The KEQ stays the same. You just get there faster. right? So the key thing with a catalyst is that you reach KEQ quicker. Awesome. Okay, go practice.